equation of motion, but let me derive it. So for me to derive it, I would prefer to use this other app I have here, that is the PTC MathCAD Prime. Okay, let's start the derivation of the equations of motion. So as usual, we said from the first equation of motion, to get the first equation of motion, we get it from the definition of acceleration. So from the definition of acceleration, so let's pull this out. So from the definition of acceleration, we can say, which is A is equals to V minus U divided by T. Now, what do we need to do next? So we need to make V the subject. So if we make V the subject, you know how to do that. That means we are cross multiplying. So now becomes AT equals to V minus U. Then by the time you collect your like terms by taking minus U to this side of the equation, leaving V alone, you now have V equals to U plus AT. So this is the first equation of motion. Don't forget that. The first equation of motion is this. Okay, now let's go to the second equation of motion. So from average velocity now, if you want to get second equation of motion, you need average velocity. So it is average velocity we use to derive second equation of motion. So how did we define average velocity? We said average velocity, which is this, is equals to, now let me use AV to represent my average velocity, which is equals to U plus V divided by 2. So this is one formula for average velocity. So average velocity can also be represented as the total distance traveled, which is S, divided by the total time taken. So these are the two equations for average velocity. So if we make the two equations equal to each other, we are going to get something like this: U plus V divided by 2, which is equals to S divided by T. So this is the two equation. So if I make S the subject here, because in the second equation, distance is our major target, I'm trying to make S the subject. If I make S the subject, I will have S, which is equals to U plus V divided by 2. Don't forget, I'm supposed to bracket this one. I'm supposed to put it in bracket. Then T will now be outside. So when you cross multiply, T is going to multiply U plus V all over 2. So this equation is very, very important. This equation is very important. So we can label this equation. Let me label it as, let me call it something like T. Okay, let me call it something like A. Let's say this is equation A. Let's take note of it. This equation is very important. Let me move up. All right. Now, referring back to the first equation, we can see that V is equals to U plus AT. So if I substitute the value of U plus AT into this place here, so this U plus AT, I'm going to replace it with this V. So I'm going to have something like this. So I'm going to have S, which is equals to T, then you open your bracket, U plus, so now remember V is being replaced with U plus 80, so it's now U plus 80. And then everything in this place, don't forget, everything here divided by 2. So at this point, we are going to collect like terms. S equals to U, which is an X equals to, then U plus U is 2U. And don't forget, let me just open the bracket directly. So this is 2U, U plus U, 2U. So I'll have 2U 2ut. Okay, we are still moving. 2ut plus 80. Everything there divided by 2. Alright. Now, to split it out finally, I will have s. I'll have s equals to, so this 2, remember, it will divide this 2, something like this. Let me just make it gently like this. Over 2, then plus 80 over 2. So we can split them out like this. Let me scroll down so you can view them. So that 2 cancel 2 here will now remaining ut, which is the same thing as s is equals to ut, s equals to ut plus 1 over 2, 1 over 2 at square. Sorry, I missed something in this place. Remember, when we open this bracket, t will times this 2u, that is 2ut, then t will also times 8. So they're supposed to be square in this place. So they're square in this place. Don't forget that. So this is the second equation of motion. Very, very important. This is the second equation of motion. Take note of this. So to get your third equation, we also need average velocity. But the only difference is what I'm going to substitute is not going to be v equals to u plus 80. I'm going to make t the subject of the formula. In the third equation, it is t I will substitute from this first equation. That means instead of substituting for v the way I did this one, I'm going to substitute for t. Let me do it on this side. So making t the subject from this equation, so I'm going to have t is equals to the same v minus u, but this time around is dividing a. So this is what I will substitute. It is t equals to v minus u over a. This is what I will substitute into this equation a. Remember the way I did it in the classroom. Just take your time and go through this video, you will understand everything better. Alright, now I will substitute this value of t into this equation a here. So let me do it down here. Let's scroll up a little. So I have my s equals to, so instead of writing t, I will write v. So let's open bracket first, which is v minus u all over a. Then open another bracket. So I need this one now, which is saying u plus v divided by 2. So it is this one I will now solve. Open this bracket, collect all my like terms, and that is all with the third equation of motion. So we continue. S equals to, if I open the bracket, you know how to open the bracket. The numerator will multiply the numerator, the denominator will multiply the denominator. So if this numerator multiply this numerator, don't forget you are moving step by step. V times u, v times v, minus u times u, minus u times v. So the numerator will now become vu. That is the first multiplication. Then you can actually use difference of two squares, but I don't want to introduce us to that yet. We are just starting our SS1. Let's leave that. Let's do our normal expansion of bracket. So vu plus v square, because v times v is v square, so you go now minus v minus u will now times u, which will give us minus u square. Let's remove this, which will give us minus u square. Then minus u will now times v. This one will give us minus vu. Everything over 2 times a, which is 2a. Let's pull this down a little. So now you can see that vu is common. So two of them will cancel out, leaving our s equals to v square. S equals to v square minus u square. So everything here divided by 2. Now if I cross multiply 2a times s, I'm going to have in my next line, let's scroll down a little. In my next line, I'm going to have 2as, which is equals to v square minus u square. Then finally, if I make my v square the subject of this formula, so if I make v square subject of this formula, u square will cross over and will now have v square alone. So v square is equals to u square, then don't forget this is already on this line minus u square, come and meet it there, it will now become plus 2as. So this is the third equation of motion. So take note of these three equations. The first one is this, which is saying v equals to u plus at. The second equation of motion is this, which is s equals to ut plus 1 over 2 at squared. And the third equation is v squared equals to u squared plus 2as. Let me copy it into our slide and let's finish up our recording of this video. Okay, now this is the first equation of, you can see it from the derivation I did. Just go through the derivation, you will understand it better. So this is the first equation of motion, and these are the meaning of all the terms. V is final velocity, u is initial velocity, a is acceleration, then t is the time taken. So if we move to the next slide, the second equation of motion. So this is also the proving, the derivation. So you can see the second equation of motion, which is s equals to ut plus half at squared. So we also go through the video on how to derive it. You will understand all these steps. So let's go to the third. So this is the third equation of motion. You can see it, which is v squared equals to u squared plus 2as. So these are the three equations of motion. Just go through them. Know how to prove this formula. They are actually easy, just for you to know your basic algebra in mathematics. I'm just doing substitution. That's what I just did. They know what is being substituted at a particular time. In that way, you will be able to derive these equations.